Okay, so welcome to chemistry. This is going to be your introduction to the different branches of chemistry, exactly what you're going to learn throughout this year. So, what is chemistry? Chemistry is the study of matter and the changes it undergoes. So, any change to where you are combining different parts of matter together to create a new molecule, the changes of matter from state to state, things like that are going to be chemistry. So matter is anything that has mass and occupies space. So anything from a single atom of hydrogen in the room right now to an elephant that would take up the majority of the room you're in, that is matter. Doesn't matter what it is, but it's going to be matter. As long as it has any kind of mass and occupies any kind of space, no matter how small or large. So mass is the amount of substance that there is. It is possible to have the same mass of oxygen molecule or oxygen atoms and the mass of a peanut butter sandwich. They can be the same thing. Mass and weight are different. We've learned this throughout your time in high school. Your weight depends on the gravity and the location of that gravity. So weight is going to be different based on where you are in the universe and where you are on Earth. So the branches of chemistry, we have organic chemistry. Organic chemistry is the study of carbon compounds. You are a carbon compound. We are made of carbon. We are made of hydrogen, oxygen. These are the stuff that we're made of. Carbon is the majority of the stuff that we'll be studying in our chemistry. Biochemistry is chemistry relating to living organisms. So this would be something like, how does your digestive system work? How do blood cells work to fight against bacteria? Things like that. Analytical chemistry is the composition of substances. So this would be taking substances and using titration to find what their different liquids are made of, breaking down solids, figuring out how to make better metals for building, things like that. That would be analytical chemistry. Inorganic is chemistry of non-carbon compounds. So this would be things like acids. And physical chemistry is concerned with the changes of matter. So physical chemistry is just talking about the change of water from solid to liquid to gas, or from solid to gas, or gas to solid. That is physical chemistry. So we'll skip the activity. So scientific method. We'll have a lesson over the scientific method, but basically this is what is used in all sets of chemistry. So it is the method of investigation. We observe a question that we have to ask. So those are our first two steps. We gather information on that specific question, and we have two different types of ways to gather information. There's quantitative, quantity, meaning number of how long something is, how fast something is, how hot, how large, something that involves a number. Quantitative is quantity. Qualitative is quality, meaning how it looks, how something smells. They are not direct measurements. So this is using any of your five senses to describe a specific object. So it looks purple. It has a funny smell. It changed color. It has a sound of a pop. You feel cool because the energy was taken in. So based on your observations, you form a hypothesis. So working to guess what's going to happen. So an inference or a hypothesis, the same word basically, they are used to answer the proposed question that you have. So once we've done that, we design an experiment to test that hypothesis, whether that be to combine chemicals together to see if we're going to change color, if we're changing the state of a matter, depending on what we're doing. So it must be able to be repeated. It can't be something that can be a one-time only. Otherwise, it is not proven. If it is repeatable, it is something that can be proven. So all tests include an independent variable and a dependent variable. So signs of a chemical reaction. This is important for chemistry. So if there is a color change or a change in smell or a gas is produced or there is heat, light or sound, or a precipitate, so two liquids create a solid, these are signs of a chemical change. So if there is a color change, if there is a change in smell, any of these show that there is some sort of new substance created. Not necessarily a brand new substance, but a new substance to the specific experiment. So based on your information that you've gathered from your experiment, you can then draw a conclusion to decide if your hypothesis or your inference was correct. If it was not correct, you may now either write how it wasn't correct, thus proving the opposite of your hypothesis, or just showing that you disproved your hypothesis and it was completely wrong, or you may find out that you have to completely repeat your test with a different hypothesis. These are all options when you come to the gathering stage. So a theory. So once you've gone through, you've repeated your experiment, you've shown that it can be tested over and over again, given the same results, but it will never be necessarily proven. It is just an explanation of why the results always show up. So a theory is considered fact, but is necessarily can never be proven. It's considered repeatable, in other words. A law. A law is something different. This is a natural phenomenon. So it explains a natural, it describes it but does not explain it. So you can the law of gravity is described as a larger mass is going to pull in something of a smaller mass. There, it does not necessarily explain it 100%. It just describes what is happening. We do not necessarily know that that is true. We just or know that that is the um, exact explanation for it. We just use that to describe what is happening, and it makes the most sense. So it basically summarizes a natural phenomenon. So, law of conservation of energy and mass. Mass can neither be created nor destroyed. It does not. It can change from one stage to another. It can change from one object to another, but they remain constant with the amount of mass it is. So whether that be you have a solid that goes through a state change into a liquid and your liquid is going to be way less than that solid, that means somehow that mass was distributed to a different point. Or energy can never be, it will be redistributed. It will never be just completely used up. So for instance, when we talk about putting gasoline in your car, you're going to burn that gasoline, but it has to go somewhere. It just can't disappear. You don't burn it up completely. That carbon is then released into the atmosphere in the form of a gas. And if you would like to do this, you're more than welcome to. What I would do is do it safely at home. You're more than welcome to do this. If you want to try to do that, go ahead. And that is the notes for today. We will discuss it in class.